Today we're going to work on finding volume using cross-sections. Let's begin. We're given that f of x is equal to the square root of x and g of x is equal to 6 minus x. Let T be the region bound by the x-axis in the graphs of f and g. Sketch region T. Well, let's do that now. Here we have our y-axis and our x-axis. Well, that's great. We know that f of x is equal to the square root of x. That would look something like this. We'll label it. And g of x is equal to 6 minus x. So we know that the y-intercept would be 6 and it would have a negative slope. So g of x would look something like that line. Great. And we know the region T is bound also by the x-axis, so this right here is region T. Let's continue with our problem. Region T is the base of a solid. For each y, where 0 is less than or equal to y, which is less than or equal to 2, the cross-section of the solid taken perpendicular to the y-axis is a rectangle, whose base lies in T and whose height is 2y. What is the volume of the solid? Well, that's a lot of work. First, we notice that the cross-section is perpendicular to the y-axis, which means that we need to set all of our equations in terms of y. In other words, we need to have f of y. So, let's start with working with f of x. Here we have f of x is equal to the square root of x. That's the same as saying y is equal to the square root of x. So, if we just square both sides, we would have y squared is equal to x. I'll rewrite that to make it pretty. We have x is equal to y squared. Great, that's f of x. Now let's set g of x in terms of y. G of x is equal to 6 minus x. We just subtract, we would have y is equal to 6 minus x. So we would just subtract 6 from both sides. We have negative 6 plus y is equal to negative x. Multiply both sides by negative 1. We would have 6 minus y is equal to x. Rewrite to make it pretty. We have x is equal to 6 minus y. Great, we have our f of x and g of x in terms of x. I'll rewrite them right here. We know that f of x is equal to the square root of x is the same as x is equal to y squared. Same equations, we're just rewriting them in terms of y. So there we have that. And we know that the solid taken perpendicular to the y-axis is a rectangle whose base lies in lies in t and whose height is 2y. So our rectangle looks like this, right? And our base lies in t. So our base itself is going to be the y, and our height is 2y. Now we need to find the area of this rectangle. We know the area is equal to base times height, so area would be equal to y times 2y. In this case, area is equal to 2y squared. So great, we have our formula for the area, and we have our functions in terms of y. We can now take the integral. So I will rewrite our area is equal to, I'll do this, you can see everything. Area is equal to 2y squared. So our volume is equal to 2. I'm taking the constant out of our integral. Here we integrate from, here we have 0, 0.